Sorry.
Here's my email for you guys. Email me if you guys have any ideas. Oh, sorry. So this is my email. You guys can feel free to email me if you guys have any club ideas, because I'm trying to start up a music club incorporated with poetry. So if you guys have any ideas, feel free to email me, and I'd greatly appreciate it. Thank you.
Yeah. Woo.
Are you going to use it? Start using what
Thank
you learned
you.
in high school and elementary school to balance your lives. Otherwise, the pressure that exists and that will come up in the next year and quarters are not going to give you any help. You might not be able to use your degree. You might not be able to use your degree. If you don't balance your lives, you might invest all this money and time for nothing. Think about it. It's very serious what the teacher is telling you. You don't balance your lives because things have become very tough. In fact, they go insane, and you know that. The demands and pressures are going to an insane degree. If you don't take care of yourselves and balance things, you will not be able to use your degrees. It's very serious. Think about it. Okay? Okay, well, let's maybe we should do the balancing now. Do the balance problem. What do you think? So you should. You remember our teacher sent this list of equations that you need to know how to derive this. It's really easy, each one of them. It's not that really hard. You should know how to derive them because one of them is going to be in your exam. Okay. Your teacher sent it to you online. If you more than a week ago. Okay, about a week ago. So you should know how to derive these equations. You start with one, you know what the letters mean, what properties, right? You understand, and you derive it. You start with the pressure, what pressure is. By definition, and you come up with this. You start from the ideal gas equation, and you find out what the molar mass is, or the density. Remember we did in lecture, right? So let's do the balancing first, and then the rest we can do maybe a couple of them or whatever, right? Okay. So which one should we do now? We can do this. Okay, so teacher always puts a problem like this in the second exam, and it asks you, doesn't matter how simple the equation is, you might be able to balance it by inspection, but because we do it by half reaction method, you have to do it that way. And as we said, you can balance by the half reaction method almost all the time without really involved with oxidation numbers or the concept of oxidation reduction at all, just using common sense. But after you do it, you will have to answer questions that they relate to the definition of what is an oxidizing agent, which is oxidized, which is reduced, and you will have to find out the oxidation numbers of the elements that they change. Oxidation numbers go from reactive to product to be able to answer these questions, right? So, okay, so let's do it, and then we'll answer the questions that they are in that problem. Now you might have used to do problems with ions, ionic equations, but the procedure is identical. It really doesn't matter if you have charges, ions. This has no ions, it's just all molecules, right? You can have ions or molecules or both. It doesn't matter. The procedure is identical, okay? So it's actually based on common sense. You don't have to know anything about oxidation reduction to do it. So we need to have reactions, balanced by mass and by charge, add them to get this. If you want to get this, you will have to have on the left, in one of these two equations, this molecule, okay? So you will have to have C2, C2H6O, space, so you can work. Very important to be disciplined and not to be sloppy. Also, don't do unnecessary things, like almost all general chemistry textbooks, when they do this job, they put the physical states, gas, liquid, and solid parentheses. It doesn't make any sense, because you have so many things to take care, and then you make it more complicated, and you still surely make a mistake. So make it simpler as possible. You don't need the physical states. It does not make sense to do it. Don't use them when you balance equations, redox equations, okay? So you just write that one. Now, it's going to be balanced. If it's going to be balanced, you need 2 carbons here, you need 2 carbons there, whatever. You need carbons here. What are you going to put? Water. What are you going to put? You have to put the CO2. Otherwise, how are you going to balance it, right? It's common sense. Okay. And then you can do the other half reaction. You will have to have oxygen. That will go to, well, what are you going to put? Even if you didn't have the H2O there, you could put H2O, because this reaction you always use to balance them, chemical equilibrium was reached. Yeah, that's what it was, chemical equilibrium. When you go them to C, you came to B, you will know that this is true. When the batteries go there, they reach the chemical system in them, reach chemical equilibrium state. So because you're using water molecules and H+, right? Even if the problem would not give you water, to balance the oxygen, what are you going to do? If you're using water, H2O and H+ to balance them, right? You will put water there. That's common sense, right? So I'm going to put water there, for the reasons I explained, and now we have the 2 half reactions. We don't care what is oxidized, what is reduced, which is oxidized or reduced, we don't really care. No physical states, don't talk about oxidation reduction. Voila. Interesting? By mass and by charge. So let's go for the first one. First by mass, then by charge. By mass first. You do all elements except oxygen and hydrogen. At the end, you do oxygen and hydrogen. First oxygen and then hydrogen. Oxygen uses water molecules, hydrogen uses H+. Okay? So the first non-hydrogen oxygen elements is carbon. So I have to balance first that. Okay? If there is more than that, all of them. There's 2 carbons here, I need 2 carbons there. That's it. So now I have hydrogen and oxygen. Which one I'm going to do first? Oxygen. Not hydrogen, oxygen. Hydrogen you do always at the end. Remember this, H+, you will have to put electrons to cancel the H+ charge. That's why they go together, so you can remember it, right? Okay, so oxygen. So we have how many oxygens do you have here? 1. 1 times 1 makes 1. 2, don't forget that 2. 2 times 2, 4. So you have 4 here and 1 there. I need 4 here and 1 there. I need 3 here. So I'm going to put 3 water molecules. Yes? This is how important it is to leave space. Always you leave space before the arrows, so you will be able to work. Because if you start getting sloppy, then you make a mistake, you will never finish it. Okay? You will get frustrated, and then voila. Okay? So it's very important. A tiny thing here, leave the space, can get you out of frustration to be able to solve more problems. Okay? You see how things work? Okay. Now, we did the oxygens and we need hydrogens, right? So, how many hydrogens do I have here? 6 times 3, 6. That's 12. So I have 12 hydrogens here. I don't have anything here, so I need 12 hydrogens. And I'm not going to put 12 hydrogen atoms or hydrogen molecules or whatever. 12 hydrogen protons, right? Cations, like this. You agree with that? If you see a mistake, let me know, because I don't want to go backwards and correct it, okay? Just don't be shy. Say it. You will not have teachers' feelings at all. All right? So now, we are done by mass, right?